In today's lesson, we're going to learn about the periodic table, why it was created, who is given credit for its creation, what this tool tells us, and what does being periodic actually mean. Although most students have seen the periodic table many times in their academic career, I found that many students don't really understand why the periodic table was created in the first place. Chemists working in the mid-1800s had roughly 60 elements that they could use to create new materials. Now, the other elements were already present on our planet. They just had no way, using their techniques, to separate them from the compounds that they were found in. For example, sodium. We have sodium every day in the form of sodium chloride, table salt. But back in the day, they didn't have a way to separate the sodium from the chloride. So there are only about 60 elements that they could purify and use. So they were searching for a way to create an organized display to categorize these materials. Why would they want to do this? To teach students about the elements, much as you're learning today, and themselves a way to organize the materials they had available to create new substances. In class, many of us have talked about having a huge pile of CDs or DVDs, and you're looking for a way to organize them. I don't know if you can see in this little cartoon, but it says Queen begins with Q, and it should be precisely here. So the gentleman here is talking about knowing exactly where his CD is based on knowing something about it. So in essence, that's what scientists were trying to do. Create a table that would categorize all the known elements at the time and have this table be useful. So not just an alphabetical listing, but a tool that by knowing where an element was on this grid, we could learn something about it. The man credited with discovering the modern periodic table is a Russian chemist named Mendeleev, or Mendeleev. I've heard it pronounced many different ways. And essentially, he used the note card approach that many of you use to study. He wrote down the known information about the 60 elements, and then sat at a table and arranged the note cards until he ended up with a pattern that satisfied his needs. He wanted to find a way to organize the elements in such a way that he could predict properties of materials by just knowing where they are on the grid. Now, what information did he have available to him? Atomic number was not known at the time, and remember, our modern periodic table, the elements are ordered by atomic number. He only had available to him atomic mass, meaning how much the elements weighed, and it was a relative weight, so hydrogen would be much less than carbon. He didn't know exactly how much they weighed. And something called combining capacity. For example, hydrogen, 2 hydrogens bond with 1 oxygen. Only 1 calcium bonds with 1 oxygen. So using these bits of information, he created a periodic table. And it looks not exactly like our current periodic table. Here's an actual picture of his table in Russian. But we can see that there are rows and there are columns, and that there are actually some spaces that were left here. And those spaces ended up being very significant in the implementation of this tool over time. There were many scientists trying to create periodic tables around the same time as Mendeleev. One of them, Mr. Newland, was from England, and he established this law of octaves. He found that if he ordered all the elements in terms of increasing atomic mass, and he lined them up, number 1 to 8, then he would take the 9th one and put it underneath the first one, he would see patterns. And since in music an octave is 8 notes, he called it the law of octaves. And we can see an example of these 8 here, and then he starts his next row. And in these columns, he saw similar properties. Unfortunately for him, he chose the word octave, so he didn't get a lot of credibility. People said, oh, science isn't music, this can't be true. So although his thinking was on the right path, his periodic table wasn't accepted as readily as Mendeleev was, although both tables actually share much of the same information. Now, the one thing that really set Mendeleev apart from the rest of the scientists trying to create periodic tables was his ability to be confident in his belief that there was such an arrangement of elements in the first place. So he passionately believed that there had to be a way to arrange all these materials so that we could see patterns in their characteristics, their traits, things like their density or their boiling points or their electron configurations. And what he did, which was very brave at the time, he left blank spots. Instead of saying, okay, you know what, my table doesn't work because there's a hole there, and if I slide everything over now, all the patterns are lost. He said, you know what, I'm going to leave spaces here. I'm going to leave spaces for elements that I think have not yet been discovered. And years after his initial publishing of his periodic table in about 1870, when these elements were discovered, it was a tremendous boost for this idea of a periodic table. In particular, he called the missing element ecosilicon because it was right below silicon. And several years later, germanium, which now exists below silicon, was discovered, and the properties that Mendeleev predicted for germanium were almost exact. And he predicted them by averaging the properties of the element above and below it, much as some of you've done in your lab activities. Now, the big kicker here is, why is it called the periodic table of the elements and not just the table of the elements? Well, the word periodic implies a variation with time. For example, we see here a picture of the phases of the moon that repeat in a cyclical pattern. So anything that varies in a predictable way can be called periodic. But it requires this resetting, that I'm going to go through the seasons, winter, spring, summer, fall, and then guess what? I start again with winter, spring, summer, fall. So it's a resetting, a cyclical pattern. So this periodic table implies that there are patterns that appear in such a way that when I go to the next period or the next horizontal row, these patterns reset. And in this picture over here, we can see this pattern of atomic sizes changing as we go across the rows. And as I reset, move down to the next period, the pattern repeats itself. Now, families are the vertical columns on the periodic table, and all these families of elements share traits, just as you share traits with your family members, whether it's the color of your eyes or what you like on your pizza or how tall you are. So I like this little schematic because although it's kind of crazy, it's called the alien periodic table, we can get the idea of understanding information in 2 dimensions. So if you get a chance, really look at this crazy little diagram here. And in our first family, we see all the aliens have 1 finger. And in the second family, they have 2 fingers and so on. And if we look as we go across the rows, across the periods, we see slight changes from one alien to the next. And as we move down our periods, we see similar changes. So not everything has to be 100% perfect, but overall the patterns repeat in a predictable way. That's why it's called periodic table and not just the table of the elements.